Prepare to experience the strongest radio allowable by law. Secrets will be revealed. Myths dispelled. From the studio gym where excuses never apply, it's Superhuman Radio with your host, Carl Lenore.
Welcome back to another episode of Superhuman Radio. Today is September 14th, 2020. And we have a great show. We really do. Those of us who are interested in building and maintaining muscle, it's funny. People used to tell me genetics play a big role and there's hard gainers out there. I always dismissed it that you just weren't eating enough, and that's why you were a hard gainer. Maybe there is something to the hard gainer story. Maybe there is actually a genetic predisposition that allows people to build muscle faster or easier. There is some science coming out of Stu Phillips' lab over at McMaster's University that points in that direction. We're going to be talking shortly with Tanner Stokes. He's been on the show before a few years ago about a study that he just authored. Very exciting, to be honest with you. Before we do that, we have to thank our title sponsor, Legendary Foods. EatLegendary.com. Use the code SHR10 to save 10% off your entire purchase. If you are a low-carb, high-protein, maybe keto, no or low-sugar person, a lot of people don't realize this. They have gut problems. They always complain about getting bloated. What they don't connect is it's the sugar that's feeding the microbes that cause the gas in their stomach. If you cut sugar way back, I predict a lot of your bloating will go away. And there's no better way to control sugar, but yet still enjoy snacking than Legendary Foods. Go to eatlegendary.com, use code SHR10 to save 10% off. Okay, let's get my ugly mug side by side with Tanner Stokes. How you doing, Tanner? Welcome back, man.
Good, Carl. Thanks. Thanks for having me on the show. How are you doing?
Very good. Very good. So this is fascinating. I'm guilty of telling people there's no such thing as a hard gainer. You're not eating enough. But apparently there looks like there's some evidence that there may be about 141 genes that may predispose someone to not gaining muscle as easily as someone else. Why this study? What needed to be elucidated that made you want to do this study?
Yeah. So first thing I'd like to point out, the 141 gene signature that you just mentioned, it's important for the hard gainer concept, the responder, non-responder. It's appropriate to first place that within context of the study design. So we did have a 10-week study design. So that's not to say that the individuals who failed to gain a significant amount of muscle in our study wouldn't have if we prolonged the study. But you are right. Some people do gain muscle, it appears, faster than others. So where'd the idea come from? It wasn't a single study that catalyzed the need or our perceived need to run this study. Really, it was, I would say, a gap in the knowledge base, at least within our field, of why does resistance training actually lead to muscle hypertrophy, or how does it happen? So we've known since people have been lifting up heavy things that muscles get bigger and they get stronger. Experimentally, that's been shown for centuries. And one thing that we realize a lot in our studies, and it's perhaps second nature to your listeners, they observe it all the time when they go in the gym, is that if they perform a series of exercises habitually for, say, 10 weeks versus someone else they see in the gym, they might notice that the other individual gains muscle much more rapidly, or ostensibly much more rapidly, or perhaps they do. So those are anecdotes, and you really don't know what's going on under the hood. Like you mentioned, nutrition, how much are they eating, how much protein are they getting, things like that. But even in the research studies that we do, if we train a cohort of individuals who are relatively similar, so say we take a cohort of college-aged males like we did, or college-aged females, you're going to get very different responsiveness to the same intensity of exercise. So if we subject a cohort to 10 weeks of exercise like we did, we might expect, if we think about muscle hypertrophy or muscle growth, that the average response might be somewhere on the order of 6%, depending on the measurement technique that you use. But around that mean response, you're going to have individuals who don't gain hardly any or no muscle at all, and you're going to get other individuals who gain much more than the mean. So really, the mean or the average response in that situation doesn't really represent that cohort of individuals very well. So what we wanted to do with our study was we wanted to take into account differences in responsiveness in the training cohort and see if we can then detect which genes are potentially driving the greater responsiveness in those higher responders relative to the low responders. So we used a few different optimized methods. The bioinformatics stuff that we did, that gets developed every year. So that's part of the reason why we were able to run this study. Optimized methods allowed us to approach this in a different manner. But essentially, I'd say that in a nutshell was the impetus, was the gap in the literature that we don't really understand what drives differences in growth responses to resistance exercise.
So explain the design of this study, because that was a great portion of the information, because you were able to do this study. As you point out, you take two groups of 10, you have them do exactly the same things. You really don't have the true information because of some of these confounding factors like genetics and who knows what else, sleep and stress and everything else. But what you did was you used individuals and you used a right leg, left leg. So we know that we see actually in this individual what's happening, right?
Yeah, exactly. So you brought up a good point. Most of these studies that we're doing, we're using small cohorts of individuals. It's because following them up for 10 weeks, giving them food, things like that, gets very expensive. So if you're comparing two groups and you want to see which genes are important, you're introducing a number of confounders by studying different individuals. So different individuals might sleep with different efficiencies. Some might sleep for 6 hours a night, others might sleep for 8 hours a night. As much as we try and control nutrition in multiple groups, you don't really know what's going on behind the scenes. Daily physical activity, so outside the gym, that matters quite a bit too. How many steps is an individual taking per day? We'd probably expect that someone taking 20,000 steps habitually would have a different response to someone taking 5,000. So that within subjects model that we decided to use, where we compare the right and the left leg, that was within the same individual. So you're eliminating a lot of those different factors. So let's say that the individual has poor sleep quality. You would imagine that it would affect one leg the same as it would affect the other leg, or at least much, much less than when you're comparing two groups of individuals. And this same thing for nutrition, right? So although one leg was inactive and the other was active, and there might be differences in blood flow to those legs, the variability within that individual is expected to be much, much less than when you're comparing it across individuals. So yeah, that was definitely one of the strengths, I would say, of our study, was the use of that within subjects design.
Well, now we can't discount that. We know that there's a phenomenon. I think I'm using the right terminology, so correct me. Of cross education, right? If you train one leg, some sort of neurological impulse occurs in the other leg in an attempt to either maintain the strength of that leg or to improve the strength of that leg. Does that come into play here at all?
Yeah, good point. So it definitely does for strength. The cross education.
It is called cross education. I was like,
yeah.
It's called. I thought cross education was when you and I sit in the same class and I fall asleep and you give me the notes later on to study.
Semantics.
Yeah.
Yeah. So it is called cross education, and you are right. So training one leg, it does help preserve at least some of the strength in the opposite leg. And the key word there is preservation of strength.
Mm-hmm.
In our study, we're looking specifically at muscle size, and at least when you're looking at large muscles like the quadriceps, which is what we're looking at, training one leg isn't really sufficient to prevent the loss of muscle mass, at least in the opposite leg.
Right.
If you look at say the forearm, if one arm is immobilized at the elbow and you train the other arm, it does look like you're able to preserve some mass in the forearm. But there's some confounders there, like can the individual move their hand in the cast, and is that enough stimuli to preserve the muscle? But anyways, to answer your question, it doesn't seem that training one leg can preserve muscle in the other. And if we do, we've done a number of studies in the past where one leg is immobilized and the other leg is just a control, and we see the same loss of muscle mass. So it doesn't seem to be playing a role, at least in our study.
Okay, so describe the study. It was kind of confusing when I read it the first time. So start from scratch. You took how many men? This was a multi-centric, right? You had men at your lab, you had men in the UK and other places, right?
Yeah, correct. So the study, so I'm in my PhD now, fourth year PhD student. This was a study that's been running for, I started it in my master's. So I started my master's actually in 2016. So running the trial was a 2-year trial. And all we did there was we recruited 14 individuals from McMaster, and we had them train one leg, as we just described, and then the other leg was immobilized during the last 2 weeks of the study. And that allowed us to do the within subjects comparison there. Now, the original aim of the study was just to see whether the individuals who gained the most muscle were also the ones who lost the most muscle. So does making you a responder on one side of the coin also make you a responder on the other side of the coin?
Interesting.
Didn't seem to be the case, at least within the 10-week period of our study. So then we wanted to see, can we determine which genes are potentially leading to the differences in outcomes between the individuals who gain the most muscle and the ones who lose the most. So we've partnered with a bioinformatician in the past, Dr. Jamie Timmons. So he's the second author on the paper. So he's really the resident expert for a lot of the RNA technology stuff that you were reading in that paper. So he's developed a new method with some colleagues who are also on the paper of analyzing the gene expression in a different way. Now, I guess for the purposes of this talk, it's not really important that we go into the nitty-gritty details of how that works. But suffice to say, it's a method that optimizes our ability to detect differentially regulated genes. So these are the genes that are going to be affected by the stimulus that we're providing. So by being able to do that, we're able to first identify more genes being differentially regulated or affected by exercise than previous studies done in the past. So we found about 2,000 in total. So that's before we did the gene signature analysis. And then what we wanted to do is we wanted to validate, or we wanted to see which of those 2,000 genes are important for growth. So if we zoom back out, those 2,000 genes were just shown to be affected by the training and the inactivity. But you can imagine that, exercise and muscle loading leads to a number of different things. Changes in strength that you mentioned, changes in muscle mass, which we were particularly interested in. There's metabolic changes in how the muscle metabolizes fuel. And so all of these different genes are playing some sort of a role in those different processes. Like I said, we were interested in just seeing which ones are determining muscle growth. So to further hone that list down to the specific, that 141 gene transcriptional growth signature, was we took those genes that were regulated in my study and we asked, are they also regulated in a similar manner and correlated with muscle growth in independent studies? So one of the issues with the research in our field is you take a cohort of individuals, you see which genes are differentially expressed, and then you follow that up with rodent work to say, okay, this one's important for growth, this one's not, all the way down the line. The problem with that, and it's probably obvious to you and your listeners, is that mice are not humans. Preclinical models are awesome. We can't do the mechanistic work that they can do, but also a lot of the things that they do don't translate into the human model. So another way you can validate the gene lists or the protein list, if that was the experiment you were doing, is to use other studies that have collected muscle tissue that have gene expression data and see if the genes are regulated in a similar manner. So it's pretty complex, but essentially our study was to identify the genes that were regulated, and then we wanted to apply a filtering strategy to see which of those regulated genes are the most important. So that's one of the strengths of our analysis, was the independent validation. And we would hope that if somebody else did the experiment, they would be able to reproduce the results a lot more strongly, I guess, than if we had just stopped after the initial analysis. So that collaborative effort was, that was with a few people from the UK that helped us on that.
And the US, apparently, right? You had somebody at the US that was working with this as well.
All over the place, yeah.
Yeah, isn't that, it's nice because, you know, when it comes out of multiple labs, there's just, I'm sure from your standpoint as a researcher, you feel like, well, there's a lot more rigor behind these results because it's not just our lab and some unique phenomenon, you know, happened here. It's like, well, they're having the same results. So I kind of feel like that's important when you can do that. It's not always possible. So describe the study. This is where I got confused. So the participants from the get-go only trained one leg. Is that correct? Or did they train both legs and then brace one leg?
No, so good point. So they trained one leg. Starting at when we recruited them, they trained one leg for 10 weeks. During the last 2 weeks of that 10-week span, the other leg was immobilized. So people were coming in to do...
So just to be clear, like let's say left leg, right leg. So let's say I trained my left leg. I did not train my right leg, but then the last 2 weeks you went ahead and braced my right leg.
Yes. Yeah.
How is so just the fact that now I can't use my right leg at all, I can't load it to walk up the stairs side by side with the left leg. That was the goal, to completely immobilize that leg, because you knew that by immobilizing it to this degree would cause some form of muscle wasting?
Yeah. So this comes back to one of the original aims, which was to use this variability in responsiveness to get at the growth responsive genes. Now, we did this in the paper. We talk mainly about the resistance training response, but those genes were compared to the genes that were expressed in the immobilized condition or the wasting condition. So you imagine one leg increased in size, the other leg decreased in size. So that was by design. We wanted that to happen.
Right.
And then by taking the differences in response between those two legs, we were able to get a better idea of which genes are regulating growth as compared to...
That makes sense.
If we had just looked at one leg resistance training. We also did a few other things in the study that are relevant. So we looked at muscle protein synthesis. We wanted to see if that was also correlated with muscle growth during resistance training or correlated with muscle loss during immobilization. So there's a few different aspects of the study. It just so happened that the focus of the journal, we thought best suited our gene results. So we focused more on that.
Okay, so 8 weeks, I'm training my left leg and not my right leg. The last 2 weeks, you're bracing my right leg. So now you're immobilizing it from any casual movement whatsoever. Was the muscle loss in the braced leg that dramatic from just not training it?
Yeah, it was pretty dramatic. So we found that, and again, when you look on average, the average response, individuals lost the same amount of muscle after just 2 weeks of immobilization that took 10 weeks to gain in the other leg. So it happened about 5 times faster compared to muscle growth. So it does occur pretty substantially, and that is pretty consistent with work that we have shown in the past. And it is pretty consistent if you just think about it. I know last time we got on an evolutionary bent. I know you like talking about that.
I love it because evolution explains everything that we learn, and we go, oh, that makes sense,
It does, yeah, it does. So obviously, muscle is an energetically expensive tissue. So if we're not using it, doesn't really make sense to keep it there. So yeah, we did find that the individuals lost muscle much faster.
So how much muscle and how did that vary between the genetically gifted and the non-genetically gifted? How much muscle did they lose once they braced that leg?
So it ranged. It ranged from it was 0.5% was the low end. So some individuals didn't lose any muscle at all. Other individuals lost upwards of 15%, and I think the highest might have been 18%. And I also would like to point out that the measurement technique that we used, or at least for that result that I just quoted, was magnetic resonance imaging. So that's kind of the gold standard for our type of work in measuring changes in muscle size. It's just the tissue differentiability with that it's unparalleled. But we did also use DEXA, so that's what they would have in perhaps a hospital. They're more readily available. And we also use ultrasound, which isn't reported in that paper. That's in another one coming up. But all of those measurement techniques led to a similar conclusion, which is that some individuals are losing a substantial amount of muscle. Others are not losing any.
And did that line up with the 141 genes that you had identified? Were you able to look at these individuals and go, oh yeah, I can see why this guy didn't lose any muscle because he is genetically gifted. Look at the genes.
Yeah. So in essence, yeah, it did. So the focus of the paper was on the resistance training response. But we did have gene expression data from the immobilized limb. And we actually did a comparison between the training limb and the immobilized limb. So if we look at the resistance training signature, there was a significant amount of mitochondrial genes that were related to muscle growth. And so if you think about when someone's inactive, again, getting back to what we were talking about energy utilization during inactivity, the body the muscle you're going to lose muscle because it's energetically expensive to maintain. The mitochondria are a significant producer of energy. And so if we're not using that energy, we don't really need as many mitochondria, or at least portions of that. So we downregulate that. And if you look at previous literature, it's pretty consistent that you see the downregulation of mitochondrial transcripts. That was consistent with our work. And an interesting finding, if we look at other mammals, so bears and squirrels, when they're hibernating, they don't actually lose very much muscle during the months of hibernation. And researchers are showing that it seems to be due to an upregulation of PGC1 alpha, which I'm sure that's come across your podcast from some of your guests before, but considered the master controller of mitochondrial biogenesis. So there does seem to be something there related to mitochondria, and that is consistent with immobilization.
So do bears and squirrels maintain their muscle, but we see a downregulation or a biosynthesis of new mitochondria, or do they become smaller? What happens to the mitochondria? Because if the mitochondria disappears, the cell has to go away. The cell can't operate without a mitochondria.
Yeah. So it's not an absolute. It's not an absolute reduction. And what they did in those studies was they took muscle from the hibernating animals, and they did gene expression similar to what we did, just to see which ones are differentially regulated with the hibernation. And they see an upregulation of a lot of mitochondrial transcripts, which goes against a lot of inactivity models in humans and even rodents. So one of the reasons why researchers are interested in looking into that is potentially developing some sort of a therapeutic or countermeasure during atrophy-inducing conditions in humans to perhaps prevent the loss of muscle mass. And it is interesting. If I just continue on that thread for a bit, we don't generally consider mitochondria to be involved in changes in muscle size per se, we consider it more to be involved in adaptations to endurance exercise. So increases in VO2 max are strongly correlated with increases in mitochondria. We don't generally consider increases in mitochondria to play a role in resistance training induced adaptations, but I guess our study would run counter to that. And there's a few other studies out there that would run counter to that. And certainly the mammalian hibernation models, are consistent with mitochondria playing a role in maintenance of muscle mass.
Mitochondria is very fascinating. I tried to get the author of a study on the show, but they're from Australia. I have very little luck getting anyone from Australia on the show because the show airs live at like 3 a.m. in the morning, Australia time.
Yeah.
And, I can't push too hard. But there's a study out there that shows that free-flowing active mitochondria in blood, meaning it's not in a cell, it's out there. It's a mitochondria, it's this organelle traveling around in blood, and it's functioning. It's not like a dead mitochondria, which is fascinating to me because we always think of mitochondria as being in cells, only in cells. So the idea that there are actually mitochondria that are flowing around in our bloodstream without a domicile to operate in makes you wonder, what are they doing? And do they contribute some sort of energetic impetus to blood or something like that? I mean, it's really fascinating stuff. Mitochondria is very fascinating. And it makes perfect sense that when you don't train, you start to become more sluggish. Yep. People always say, oh, I'm always so tough. Well, get to the gym and train. And they go, I don't even have the energy to go to the gym. But if you start training, you'll have energy. So that makes sense there. What about the 2-week window? I think most of us who have been training know that, like, if you take off for 2 weeks, that's when you start to notice changes in muscle size. Mm-hmm. This kind of played out in this research, did it not?
So that didn't play a role in the resistance training response because while the one leg was immobilized, we had them train the other leg. So I guess so the cross education was working then, but once you completely immobilize the leg, mm-hmm. then all bets were off. Things start to fade away. Yeah. So the leg that was immobilized didn't train at all, though. So that would definitely happen if you trained a limb and you increased its muscle size and then put a brace on it. Yeah, you'd revert back to baseline values pretty quickly. Yeah.
And didn't you say that the amount of muscle that was lost in the 2 weeks of immobilization was equivalent to the amount of muscle gained in the 8 weeks of training?
Yeah. So that was on average.
That shows from an evolutionary perspective that the body knows, like, hey, we need to get rid of this stuff fast. Mm-hmm. And that's why building muscle is hard, because it is metabolically expensive and the body wants to know, can you maintain this? Before you take on this debt, will you be able to sustain it? And it's just fascinating to me that it's like flipping a switch. The body goes instinctively, we need to offload all this muscle because we're not gathering the calories and we're not doing the work. And, we need to do, it's really, all of this stuff has to be done in the lab to understand, but it always comes back to the evolutionary edicts. It really, really does. It's just fascinating to me. We're going to take a quick commercial break. I've got lots more questions. We're talking today with Tanner Stokes. He is a Ph.D. student at McMaster's in Stu Phillips' lab, where they do all of this fascinating work. You've got to love what you do, right? It's just fascinating.
Yeah, it's my playground.
You get excited. I was going to say, you probably get excited to come in every day. All right, stay tuned. We'll be right back.
Quest Nutrition makes bars, cookies, chips, and pizzas out of complete dairy-based proteins. Our products minimize net carbs and sugar without sacrificing taste. Each delicious chocolate-flavored chip, Cookie Chunk and Crunchy Crumble is custom made to maintain Quest macros. It's time to enjoy foods that work for you, not against you. It's time to enjoy your Quest.
I love beef. And if you love beef, listen up. I've discovered the best tasting beef in the world, and that's not an exaggeration, at Piedmontese.com. The Piedmontese breed is famous from Italy for being lean and unbelievably tender, with half the fat and calories of traditional beef. Even typically tough cuts are tender when it comes from the Piedmontese cows. And for the first time ever, Piedmontese cows are being raised here in the USA. Get 25% off all beef and free shipping on orders of $100 or more at Piedmontese.com with code SHR. Go to Piedmontese.com and use code SHR today. You will never eat any other type of beef ever again. Everybody wants to feel better, be healthier and happier. If you don't sweat profusely on a regular basis, you won't feel as good as you could. Studies have shown the power of infrared sauna. Infrared penetrates 1 to 2 inches into the body. It helps those with back pain, fibromyalgia, arthritis, depression, and anxiety. Patients get relief from infrared sauna. The Good Health Sauna has been shown to be an exercise mimetic, conveying many of the same benefits as cardio. There are a lot of reasons people buy a Good Health Sauna, but the bottom line is you will be a much happier, healthier person by using the Good Health Sauna every day. You'll crave it, you'll love it, and it will be the best purchase you have ever made. Good Health Saunas provide commercial-grade saunas for in-home and commercial use, backed by the best lifetime warranty in the industry. Unmatched customer service and the best financing makes owning one easy and will fit any budget. Go to goodhealthsauna.com/superhumanradio to learn more and save 25% off. Did you know that your gut is referred to as your second brain? In fact, at least 90% of your serotonin, your happiness chemical, is created in your gut. If you don't take care of your gut, you won't feel good, period. Bioptimizers recently released Cognibiotics, a new breakthrough probiotic formula that is clinically proven to enhance your brain function, your mood, and overall mental health. Most probiotics often include conflicting strains or quantities and can cancel each other out. Cognibiotics delivers the exact strain you need in exactly the right ratios and quantities. With a 365-day, no questions asked, money-back guarantee, you can try them out for yourself to start feeling the incredible difference Cognibiotics makes in your mood, mind, and performance. For an exclusive offer to my listeners, go to cognibiotics.com/SHR. That's COGNIBIOTICS.com/SHR and use code SHR10. You've heard me talk about the chill pill on the show and how effective it is at helping people who suffer from social anxiety, or sometimes when you just want to take the edge off to a long, stressful day. Well, listen to this story from Dylan Goutreau.
Definitely takes anxiety away, which I have a long history of having. Started out at 2 milligrams a day of Xanax. That was at 8 years old. And so I stopped using benzos 3 years ago. Extremely difficult. Yeah, so I spent about 3 years trying to find anything and everything I could that would be healthy for me to help with anxiety. Because I'm talking, full out panic attack. The chill pill was the first thing that I found that actually in the middle of a panic attack I can take, and it definitely subsides.
Go to drseeds.com. That's DRSEEDS.com. Use coupon code SHR and save 20% off your first bottle of the chill pill. Check it out. I promise this is one supplement that delivers.
Mind Bullet is a kratom product derived from the coffee family to boost energy and creative juices. Mind Bullet comes in both pill and liquid form for the ultimate pre-workout supplement. When needing a little pick-me-up or to get through the morning fog, Mind Bullet will set your productive course fast. Go to shrnetwork.biz/mindbullet, all one word, today, and save 20%. No subscription required. That's shrnetwork.biz/mindbullet. Get yours today.
This is the Superhuman Channel, where we use oxygen for the power of good.
Welcome back. We're talking with Tanner Stokes. We're talking about 141 genes that appear to provide individuals fortunate enough to have the proper genetic array to build muscle and even maybe maintain muscle a lot easier than other people. Before we move on, I have to just tell my listeners that you just heard the spot for Good Health Sauna. You can win a 3-person $5,700 infrared sauna from Good Health Sauna. You just have to enter to win at shrnetwork.biz/free sauna. This is a wonderful opportunity. If you don't have, I have a sauna at home. I love sauna. And sauna actually does so many beneficial things. We did an entire show about sauna. Dr. Rhonda Patrick recently did a fantastic podcast and newsletter not recently, maybe a few months ago, showing that sauna is an exercise mimetic. And you don't, right now, all the gyms, the saunas are closed because they're afraid you're going to get COVID in it, which is silly to me. But nonetheless, you can have a sauna in your own home. This is a 3-person sauna. It fits in the corner of a room, doesn't take up a lot of space. You put it in your bedroom. I don't care if you have a studio apartment, you can put it in your apartment. Go to shrnetwork.biz/free sauna to enter today. Did these subjects keep diaries? Did you ask them any questions about their diet, their sleep, their lifestyles at all?
Yeah. So with the longer duration studies, obviously we would love to give them all of their food. And if the study is a couple weeks long, we do. You can imagine it gets pretty cost prohibitive for as we stretch out to 8 to 10
But
weeks.
do they even eat all that food? The nice thing about rodents and dogs and all these other species that we use for the initial testing is we can put them in a cage. We know how much they move. We know what they're eating. Humans are notorious for underreporting what they perceive as bad behavior and overreporting what they perceive as good behavior. And I would imagine even if you give them the food, like we're talking about young men, right? In this study?
Yes, correct.
So they're not going to tell you the truth that they went out Saturday night and and did some ecstasy and drank all night long. I mean, they're not going to tell you these things. So is giving them their food, is that really effective, do you think?
So it's definitely more effective than dietary recall. So in our study, we did dietary recall or journals. We, like you said, we did ask them to record what they're eating, and obviously we are taking them at their word. I will say that when you're recruiting individuals, especially college-age men, you can get a good sense of who's lying to you. At least I felt that good. We did actually find a couple individuals who are non-compliant, and we removed them from the analysis. So there are different ways of calling people out, I guess you could say. But in essence, they gave us food diaries every couple of weeks. And what we were particularly interested in was protein intake. So that's the other side of our research, is the influence of protein intake on muscle growth, especially during resistance training or loss during immobilization. So we were mainly concerned with that. It turns out, and this isn't particularly surprising, they ate more than the recommended dietary allowance of 0.8 grams per kilo. And they were actually consuming, based on their reports, what would be considered the maximal amount to maximize the adaptations to training. So it's not to say that the protein was driving differences in the responsiveness. There was other research done showing that above that recommended dietary allowance, that can explain differences that we see between individuals.
Was there anything that you saw that you think could be harnessed to help people build muscle faster or maintain muscle longer?
Do you mean supplement form?
Anything. Like, did you notice that, like, if people did this, they would maintain muscle longer? If people did this, they'd gain muscle faster. Is there a way for us to influence those 140 plus genes?
Yeah. So in essence, I would say that you need to do more research, and certainly future research that could be done in this area is figuring out why these individuals are expressing these genes to a greater extent than the lower responders. And it is potentially related to what's called epigenetics.
That's what I thought. Yeah.
Yeah. So we can attach our cells can attach essentially methyl tags to genes, or at least the regions that are important for expression. And that can silence or can promote expression of a gene. So it could be the case that individuals who aren't responding as well, again, you do respond in other ways other than muscle hypertrophy, it is possible that they have greater level of methylation, or these epigenetic marks that are preventing the cellular machinery from transcribing the relevant gene which could then be reflected downstream in our results. Because the results that we looked at the mRNA, it would be downstream of any epigenetic effects. So we wouldn't be able to capture that. But there are similar methods that you can use where you can look at the level of methylation. So certainly that's an area for future research. But to get to your question, can we help these individuals who maybe they didn't win the genetic lottery and they have all these methylation marks? Perhaps, I don't know if supplements would help in these individuals. It's possible. Another thing I would say is that a lot of the times, if you precede resistance training with aerobic training, sometimes you can remove a lot of these methylation marks. Now, whether that occurs on the genes that we're interested in looking at here.
So wait a minute. So you're saying that by remove some of these methylation marks, are you saying that you can turn these genes off or on?
So it depends. Usually it would be turning them on, because when you have these methylation marks, that usually corresponds with silencing of that gene. So if we can remove it, again, not always. I don't like the words always and never. But under most conditions, that would turn the gene on, or at least make it more responsive to a stimulus. Another possibility is that these individuals who didn't respond during the first 10 weeks would respond if we asked them to do another 10 weeks of exercise. So that's also possible, and that was shown in a cohort of older individuals by a Dutch group. So it's possible.
What about hormones? Did you do blood work on these individuals? Did you look at hormones that we know have an anabolic effect, like testosterone or even estradiol? We know estradiol actually plays a role in anabolism. We know that certain metabolites of progesterone. Did you look at blood work?
So we have blood collected. We haven't analyzed it yet. That's perhaps downstream, but who knows what's going on with COVID and when we'll be able to do all these analyses again. Obviously, collaboration slowed down. But to answer the question about the hormones, testosterone, for at least in our group, it hasn't been shown, at least within physiological ranges, to lead to substantial hypertrophy, or at least differentiate somebody who's a higher responder from someone who's a lower responder. Another PhD student in our lab showed that the androgen receptor within the cell, that's a different story. So a greater content of the androgen receptor could potentially lead to greater increases in muscle size with resistance training.
So you're saying more androgen receptors could be affecting it, but then wouldn't that be because more testosterone has places to dock? I mean, the androgen receptor by itself in a vacuum isn't doing anything. It's not going to transcribe anything until something docks in it and stimulates it, right?
Yeah, no, it's possible. Just in the research that we've done, the differences in testosterone concentration, they can explain the differences in muscle mass gain with resistance training. And now, obviously, that's within the physiological range. If you start adding testosterone to the system, then that's a different story.
What about some of these other growth factors that seem to be produced inside the muscle as a result of congestion? A lot of people are using blood flow restriction today. They're seeing lots of results as far as building bigger muscle, not necessarily, I don't know about the strength side of it. Are any of those growth factors playing a role with these genes from an epigenetic standpoint, you think?
Yeah, it's certainly possible. I'm not too familiar with the blood flow restriction literature, especially as it relates to epigenetic modifications. I do know that blood flow restriction leads to a quicker accumulation of metabolites within the muscle, which is thought to lead to quicker fatigue. And so another avenue of our research shows that lifting to fatigue or to failure is really that's the important point, whether you're lifting heavy loads or whether you're lifting low loads. So the blood flow restriction crowd, they're just leveraging another method of getting to muscle failure or fatigue quicker. At least that's my understanding, and it leads to Yeah, it leads to greater accumulation of metabolites, which definitely there are metabolites that can affect epigenetic modifications. And the development of those chips to be able to look at the methylation tags or sequencing, it's only improving. So I think that's definitely going to be an area of future research investigation, is looking at those tags, because if you think about it, the signaling from a resistance exercise bout, it's going to activate phosphorylation cascades, things like that, and alter epigenetic modifications perhaps before it affects gene expression under a lot of different conditions. So again, these things all work best when we combine different methods. So you can combine methods to look at epigenetic modifications and then look at gene expression and then look at protein expression in the same individual. Mm-hmm. That's the ideal situation. Unfortunately, that's very, very cost prohibitive for the stuff that we do. So at least at the moment, what we do is you pick one, you pick the one that you think is going to yield the best results. And then you have to make inferences about, why are the changes in gene expression happening? Well, maybe it's epigenetic marks. And then you look at the epigenetic marks. Are the differences in gene expression leading to differences in protein expression? You got to look at the protein expression. So these things need to be combined. But the hormones, definitely an avenue where it's controversial. I think right now did you
take blood? We're going to take a break, and I have a question for you on the other side of the break.
Sure.
Did you take blood on a weekly basis? How often did you take blood throughout the 10 weeks?
So we did the blood every other week when we got the food diaries.
Perfect. All right, let's take our last commercial break, and we'll wrap up this discussion. When we come back, I want to talk a little bit about myostatin.
Okay.
One would expect that if muscles are getting smaller, myostatin is at work. But one would also think that would be at work systemically. Let's just talk about myostatin when we come back. Stay tuned. We'll be right back. Whether your goal is to build muscle or burn fat, you'll find everything you need at Redcon One. Need help getting a good night's sleep? Try Fade Out, or the most popular pre-workout supplement on the market today, Total War. Sign up for their new Transformation Challenge and win $10,000, or shop for apparel that people at the gym will know that you are serious about your training. Need a testosterone booster that works? Check out Boomstick. Whatever you need, you'll find the best quality supplements on the market at Redcon One. Go to redcon1.com. That's REDCON, the number 1.com, or go to superhumanradio.net and click the Redcon One banner ad today. Chronic stress leaves us tired, distracted, and physically vulnerable. Apollo Neuro is here to help you take control. Apollo Neuro is a new wearable that trains your nervous system to be more resilient to stress. Apollo's gentle vibrations use your sense of touch to help you recover from stress, going from fight or flight to rest and digest, so you can relax, get to sleep, focus, and stay healthy. Developed by physicians and neuroscientists, Apollo Neuro has been tested in multiple clinical trials and is proven to improve heart rate variability, the key biometric of stress. Special offer for friends of Superhuman Radio. Try Apollo Neuro today and get 15% off your purchase at apolloneuro.com/superhuman. That's APOLLONEURO.com/superhuman. Do you remember those delicious toaster pastries you had when you were a kid? You know, the rectangular sugar-filled snacks? Well, guess what? Legendary Foods has just made low-carb toaster pastry. This is the first of its kind, and honestly, these things are amazing. They have 3 to 4 net carb, less than 1 gram of sugar, and 9 grams of protein. You can eat them right out of the wrapper or lightly toast them. The only question is, which flavor? Strawberry or brown sugar cinnamon? They're available at eatlegendary.com and Amazon.
When craving a snack, reach for Select Savory Snacks Sugar-Free Biltong, the healthy alternative to sugar-laden beef jerky. They use a fattier cut of beef, making it more tender and flavorful. For mealtime, choose from their 63 seasonings, which are sugar and additive-free. From chipotle rub to savory pumpkin spice, you'll find an option to suit your palate. Go to shrnetwork.biz/SSS today. Use code SHR15 to save 15% on any meat snack or seasoning. Savor the flavor today. Among the easiest and most popular ways to experience the life-altering benefits of hemp, Planet Earth CBD soft gels offer fast-acting effects as they release quickly. Made in a GMP-compliant, US FDA-registered facility, you can count on Planet Earth's safe soft gels. These soft gels provide temporary relief from pain and so much more. Manufactured with the calming combination of chamomile and melatonin, you got yourself a long-needed CBD solution. 25 milligrams of nano-emulsified hemp extract per serving with anti-inflammatory agency. Planet Earth sleep-supporting soft gels will have you forgetting about today's worries for a better tomorrow. Unwind with Planet Earth CBD today.
New Mass Pro Synthogen X2 just upped its own legendary game. To distance itself even further from the rest of the pack, Synthogen X2 now has double the key active ingredients. If you've ever wondered what steroid-like recovery feels like, Synthogen X2 delivers. See why others compare it favorably to powerful bodybuilding drugs at synthogen.com. Mass Pro Synthogen. When you train with it, you'll gain with it.
You're listening to the Superhuman Channel. Don't hate us because we feel good.
Do you enjoy Superhuman Radio? Have you learned anything from the years of publishing 4 and 5 shows a week? If you have, I'd appreciate it if you would go to shrnetwork.biz/yourstory and tell me your story. Tell me how Superhuman Radio has affected you, maybe your family. Doesn't have to be very long. It could be 60 seconds, 30 seconds. Just keep it under 3 minutes. Point your iPhone or your smartphone at your face, turn your video camera on, and upload the video at shrnetwork.biz/yourstory. I'm asking everybody to do this. And maybe I suck. Maybe you think I suck. I'd like to hear that too. What do I suck at? What should I get better at? Do I pronounce words wrong? I'm kind of like the Norm Crosby of health and fitness. I've been ridiculed in the past for pronouncing rapamycin with too many A's in it. So, let me know what you think of me, of the show. I appreciate it very much. We're talking with Tanner Stokes. We're talking about some genes that play a large role in whether or not you build muscle easily and effectively. So myostatin is a negative regulator of muscle. It's an evolutionary gift. It's exactly like we've been talking about. Get rid of offload muscle when you don't have the need for it because it's metabolically expensive. When you look at the blood work, will you look at myostatin levels?
So we won't probably in our study, but the issue with that is being able to reliably detect myostatin. And certainly back to your point, it does seem to be playing a large role in loss of muscle mass and maybe potentially preventing growth during training. The problem is most of these studies are done in rodent models, or you extract cells from humans outside of the physiological environment in a petri dish. And if you treat it with myostatin, it leads to loss of the sarcomeric proteins and things like that. The problem is in the human condition, it's not relating, at least in the statistical analyses that we do, and maybe the effect is too small to pick out, but it's not driving the growth response. And again, maybe over prolonged periods of time, it is having more of a pronounced effect. I'm just within the context that I can only speak within the context of what we're doing.
Right.
It's not linear, at least linearly relating to growth, loss of muscle. I will point out, though, there was a recent study that was just published not too long ago where they blocked myostatin or targeted it in mice that were sent up into space, and it did prevent the loss of muscle mass. So
yeah, but see, I don't want people to get too excited about myostatin for a second.
Yeah.
I communicated with Dr. Se-Jin Lee early on when he discovered myostatin. He wouldn't come on the show because he was trying to cure diseases, and he felt that my desire to understand myostatin was selfish. We wanted to build muscle so we look better and all that sort of stuff. But he communicated with me quite a bit. And the State University of New York, I think it was Rochester, published a study 8 years ago that we covered. We had the author on the show. And the thing that's confusing about myostatin is that all the research in myostatin is done on myostatin null animals.
Yep.
That are myostatin null in the womb. They start out that way. And our desire to harness myostatin is in mature muscle, which is a completely different thing. And they showed in the study from Rochester, I believe it was Rochester, but it was definitely State University of New York, that you must suppress myostatin by like 92% in order to see any effect at all. And that suppression needs to be continuous and prolonged. And the real magic was up at like 97%. But once you stopped suppressing it, you lost all the gains. And then there's the whole other thing that myostatin builds big muscles, but not necessarily strong muscles or not necessarily strong soft tissue. There's a higher rate of shearing muscles off of bones and all that sort of stuff. So when we talk about myostatin, I don't want people to get excited about it. The only context I'm trying to understand is if myostatin is negatively regulating the muscle in the unworked and immobilized leg, I would think that's systemic. How does it just target that leg? Why wouldn't it target the entire body? Why wouldn't we see a complete stall of muscle gains? You know, I would love to see your study done again where they train both legs and see if training both legs resulted, the same subjects, resulted in the same exact gains in the trained leg as the two trained legs, or did they gain more because there's a system-wide suppression of myostatin? That's where I was thinking about.
Yeah, no, that's a good point. Always future research needs to be done. To get to your point about systemic myostatin, the reason why is because of the receptors are expressed to different concentrations in different tissues. If we think about muscle, it's dense in the receptors, so it's going to be a primary target. Another thing I will mention is that
great point. Okay, go ahead.
Yeah, so we can also look at the expression of those receptors and how they're changing in muscle. And again, it's not leading to any differences, at least with the loading or unloading context that we provided. And to your other point about the substantial suppression in that other study, I'm not actually familiar with that study, but I'll have to check it out. I think what we have to also consider is the off-target effects of doing something like that. So maybe it does promote muscle growth, but what else is going on in, say, maybe the heart or somewhere else? So an example of that, mTORC1 is probably another popular topic of conversation on this podcast. So in our field, mTORC1 is considered one of the primary regulators of muscle mass as well, much like myostatin. So people think that if you can stimulate it to a greater extent, potentially you could gain more muscle, but at least research in rodents is showing that overexpression or overactivation of mTORC1 actually leads to dysfunction and
because it has to pulse. mTOR and AMPK, if you turn mTOR on all the time, the body goes, we're not responding to that all the time. So it has to pulse. We know. And in fact, Wednesday, I have an amazing show. I was going to wait till coming out of the break to talk about it. But I take 6 milligrams of rapamycin once a week as part of, I'm 62 years old and I'm trying to leverage the science that will help me extend my health span and my strength. But one of the things I've always wrestled with was like, it's shutting off mTORC1. And now Dr. Mikhail Blagascloni has been on this show ever since 2012. And he's the guy who did all the research early on. In fact, his research was rejected by major publications, his early research on rapamycin and senescent cells. Boy, he's laughing now. But anyway, he said to me, Carl, rapamycin will not interrupt protein synthesis. I said, but it shuts off mTORC1. We know. He said, no, it doesn't shut it off. Well, Wednesday, we have an author of a study that just showed that elderly people who took rapamycin for anti-aging gained muscle. And they are thinking that the reduction in senescent cells in muscle allowed the muscle not to undergo wasting, which is going to be fascinating. And I'm going to ask about mTORC1 and all that sort of stuff during that interview. But one of the reasons I won't take, and I've never taken metformin. And now it's coming out that a lot of the people early on the metformin train are going, no, you know what? We're not taking it. Is because all the research on metformin has been done on sick individuals, not healthy individuals. And it has been shown effectively to completely blunt and shut down mTORC1, which goes back to the initial comment. It's got to be a pulse. Turn it on. Same thing with autophagy. We know that autophagy is important for protein synthesis. People go, how could that be? Because autophagy turns on and then it turns off. If all you try to do is turn on autophagy all the time, it's not effective at doing the things that you want it to do. So it's really fascinating that this pulse of so many things, even growth hormone. You know, they did research on idiopathic short stature. They gave these kids 40 IUs of growth hormone a week. One group they gave an equal dose 7 days a week. The other group they gave random doses on random days, but it still totaled the 40. And the kids who got the 40 IUs a week randomly had greater growth. So the body likes to turn things on and turn things off, is my point.
Oh yeah, I agree. Completely agree. Yeah.
So what will we see next? What's the next phase of your research?
Well, you know what? I would love to follow up this stuff and look at some of the signatures in greater detail, but COVID is holding me up right now, and I do have to complete my degree. So if I get back into the lab, potentially looking at some of these genes more in an isolated context to see what the mechanism is. So perhaps in cell culture, just to really divulge the mechanism thoroughly. But whether I'll get to that before I have to wrap up, I couldn't tell you. I hope so.
So here's a question from Faith Fitness Guy. He says, what is your view on mitochondrial support supplements helping to stimulate an anabolic response like a biohack? What do you think? You put any faith in that?
Well, you know, I would resort to an analogy that my supervisor, Stu Phillips, likes to use. When you like wringing out a towel or wringing out a cloth, that's like resistance exercise is the first ring. You get most of the bang for your buck by doing that. Supplements, you get a little bit extra out of it, but not quite that much. Is it going to play a role in the epigenetic mark stuff that we were talking about, or potentially helping those individuals who are low responders? Could very well be. I don't know. But good question.
What are your thoughts on intermittent fasting? Are you a fan, not a fan? What do you think?
That's a very contentious topic in our field. So the autophagy thing that you're talking about, obviously intermittent fasting is going to stimulate that. So I did intermittent fasting, and I liked it just because of not having to get up and eat something before I start my day and things like that. So it was more of a convenience thing. If you do head-to-head comparisons, at least for weight loss, there's not much there. If you look at autophagy, obviously one's going to be better than the other. The problem with a lot of these things, to fully elucidate or answer the question how we want to satisfy us, would be to develop better methods of looking at it. So rather than looking at the the static state, taking a muscle sample and looking at the expression of, say, an autophagy gene or protein with intermittent fasting, we would want to see how autophagy is changing over time as a rate. And that can give us better indication of what you're talking about, the fluctuations, which I agree are probably the important thing.
Because didn't Stu do a study, or I want to say maybe it wasn't him, but didn't he do something with the intermittent fasting and showed that it did not cause muscle wasting because the body is efficient at recycling amino acid pools during the fasting phase? Oh, training fasted. Didn't he do something with training fasted?
Yeah, probably. There's definitely studies we have. Yeah. It's not, you're not, I don't think you'll lose muscle mass from training fasted. With regards to the intermittent fasting for weight loss stuff,
any calorie reduction is going to give you the same results. Any calorie.
Yeah. But I wouldn't worry about training fasted. You know, certainly some people.
I use intermittent fasting from an anti-aging standpoint, but I do train fasted, and I don't worry about it because I just started training again, and it's remarkable to me how fast I'm putting muscle back on. Mm-hmm. And I took a lot of time off between. So last year I had, let's see, 2019, 18 and 19, I had 2 foot surgeries, immobilized the left leg, lost my calf doesn't look like it belongs to my leg anymore. I have to build that back up. But the past couple years I haven't been training. I've lost so much muscle, and I've just been training for the past 2.5 weeks. And I'm astonished how fast I'm putting muscle back on.
Are the gyms open there? Where are you in the States?
Yeah, in Kentucky, Louisville, Kentucky. The gyms are open.
Yeah, they're just starting to open up here. Interesting.
This is disastrous for those of older guys like me. I've always said, the slide down the hill is much faster than the climb back up. I lose strength so quickly now, where I could have taken off for a week and gone into the gym and hit my goals. Now I can't. I have to go slow, and that speaks to what your research is. Listen, I want to thank you so much. Okay, you were going to say something. I'm sorry.
Oh no, I was just going to say that the research is definitely consistent with that. You lose it faster than you gain it. That's for sure. Yeah.
Hey, I can't wait to have you back on, because you will have your doctorate back by then, right? You'll have your
fingers crossed. Yeah.
All right, we're rooting for you. I'm looking forward to seeing you again. Thank you so much for being on the show, Tanner.
Okay, thanks, Carl.
Take care. We're going to take one quick commercial break. I want to tell you about next week. I kind of let the cat out of the bag a little bit, but there's some other things I want to talk about. Stay tuned. Are you still on the fence about body protection complex B.P.C. oral from drseeds.com? Listen to Maggie Kuhn, one of the owners of the C-Bus lifting company gym in Columbus, Ohio.
I had been having some nagging tendon issues that weren't injuries, just things that were annoying. I'm 58 years old, so just older tendon kind of issues. For us powerlifters, we really don't stop training when we have just nagging issues. We just kind of keep pushing through. And I started the BPC. What I noticed was I was doing some heavy tricep stuff that would have killed me before when I had an elbow problem, and I was able to do this with literally no pain at all.
Go to drseeds.com, drseeds.com. Use coupon code SHR and save 20% off your bottle of BPC Body Protection Complex today.
Want to improve mental energy and focus? Try the new Superhuman Stack from Pure Nootropics. Stack Dynamine, L-Butamin, Theocrine, and palmitoyl ethanolamide together and feel the lights go on in your brain. Find your perfect mix of these 4. Carl likes 1 cap of each and 2 caps of Dynamine. Bam! Lights on. Go to shrnetwork.biz/superhuman stack, all one word, today, and get yours for 25% off plus free shipping. That's shrnetwork.biz/superhuman stack.
You've heard me talk about the chill pill on the show and how effective it is at helping people who suffer from social anxiety, or sometimes when you just want to take the edge off to a long, stressful day. Well, listen to this story from Dylan Goutreau.
Definitely takes anxiety away, which I have a long history of having. Started out at 2 milligrams a day of Xanax. That was at 8 years old. And so I stopped using benzos 3 years ago. Extremely difficult. Yeah, so I spent about 3 years trying to find anything and everything I could that would be healthy for me to help with anxiety. Because I'm talking, full out panic attack. The chill pill was the first thing that I found that actually in the middle of a panic attack I can take, and it definitely subsides.
Go to drseeds.com. That's drseeds.com. Use coupon code SHR and save 20% off your first bottle of the chill pill. Check it out. I promise this is one supplement that delivers. I love beef. And if you love beef, listen up. I've discovered the best tasting beef in the world, and that's not an exaggeration, at Piedmontese.com. The Piedmontese breed is famous from Italy for being lean and unbelievably tender, with half the fat and calories of traditional beef. Even typically tough cuts are tender when it comes from the Piedmontese cows. And for the first time ever, Piedmontese cows are being raised here in the USA. Get 25% off all beef and free shipping on orders of $100 or more at Piedmontese.com with code SHR. Go to Piedmontese.com and use code SHR today. You will never eat any other type of beef ever again.
Among the easiest and most popular ways to experience the life-altering benefits of hemp, Planet Earth CBD soft gels offer fast-acting effects as they release quickly. Made in a GMP-compliant, US FDA-registered facility, you can count on Planet Earth's safe soft gels. These soft gels provide temporary relief from pain and so much more. Manufactured with the calming combination of chamomile and melatonin, you got yourself a long-needed CBD solution. 25 milligrams of nano-emulsified hemp extract per serving morning with anti-inflammatory agency, Planet Earth sleep-supporting soft gels will have you forgetting about today's worries for a better tomorrow. Unwind with Planet Earth CBD today.
Did you know that your gut is referred to as your second brain? In fact, at least 90% of your serotonin, your happiness chemical, is created in your gut. If you don't take care of your gut, you won't feel good, period. Bioptimizers recently released Cognibiotics, a new breakthrough probiotic formula that is clinically proven to enhance your brain function, your mood, and overall mental health. Most probiotics often include conflicting strains or quantities and can cancel each other out. Cognibiotics delivers the exact strain you need in exactly the right ratios and quantities. With a 365-day, no questions asked, money-back guarantee, you can try them out for yourself to start feeling the incredible difference Cognibiotics makes in your mood, mind, and performance. For an exclusive offer to my listeners, go to cognibiotics.com/SHR. That's COGNIBIOTICS.com/SHR and use code SHR10.
This is the Superhuman Channel, doing reps with the weight of the world.
Welcome back. I'll be real brief. So I kind of gave away Wednesday's show. It's going to be very exciting. We have a problem with Facebook right now. For some reason, StreamYard can't post the show on Facebook, so I may be just doing the show on YouTube the rest of the week. We'll just have to see what happens. But Wednesday's show is going to be phenomenal because rapamycin possesses so many benefits for aging individuals that it's uncanny. But the one thing that I always worry about, even though I take my 6 milligrams once a week, is, you know, am I going to lose any muscle or maybe not gain any muscle if I train? Is it a bad idea? In fact, I even fast. Rapamycin has a 3-day or 2-day half-life. So I generally don't train and fast on Wednesday because that's when I take it. And then I pretty much, and when I say fast, I fast for, like right now, I stopped eating last night at 5 o'clock. So at 5 o'clock today, it'll be 24, or 4 o'clock today, it'll be 24 hours. So I generally, when I fast right now, I'm not doing a 16-hour fast. I'm doing a much more aggressive fast because I'm trying to get my act back together. I feel better and I train stronger, believe it or not, when I'm fasted. But getting back to rapamycin. So when I take rapamycin once a week, the 6 milligrams, I generally fast like at least 20 hours on Wednesday and at least 20 hours on Thursday because I want to leverage what rapamycin does. I want to get rid of as many senescent cells as possible. I want to lower the burden of energy requirements by my gut and digesting food. And I want to, turn autophagy up as high as I can for those 2 days. But it looks like rapamycin may actually enhance muscle gains. This is shocking to me. This show Wednesday will be fascinating, I promise you. What they did was they used rapamycin in elderly people, and it stopped them from losing muscle. You know, look at the discussion we just had. Well, if it stops elderly people who aren't training from losing muscle, if it stops the hold of I want to say sarcopenia, then what does it do for elderly people who train? Could it actually enhance anabolism? I mean, I'm excited about that. I'm hoping I may change. I may take my rapamycin on Wednesday and train Wednesday, Thursday, and Friday and take off Saturday to leverage it. One thing is for sure, rapamycin is really fascinating. And for a long time, I have talked bad about metformin because all of the science on metformin is in sick people with type 2 diabetes that are in horrible shape. In healthy people, it contributes nothing, and it may actually contribute a slower gain in muscle in healthy people because it does inhibit mTOR-C. Dr. Blagascloni said on this show, last time he was on the show, he said rapamycin does not inhibit mTOR-C. It gets rid of senescent cells through a completely different pathway. And he's the guy when it comes to rapamycin. He's it. Everybody's learning from the things that he's doing. So, and a lot of thought leaders who were on the metformin bandwagon a while ago have now abandoned it, including Blagascloni was a big fan of metformin. He says, no, it only helps people who are sick. It doesn't help people who are well. And hell, you can get the same benefits from intermittent fasting as you can from rapamycin. So intermittent fasting helps get rid of senescent cells. It helps balance blood sugar. Anyway, so Wednesday's show is going to be fascinating because it'll take the brakes off of anyone who wants to use metformin, rapamycin, and stop them from worrying about losing muscle mass. Number one, that's big. Number two, Dr. Blagascloni is looking for physicians to train. If you're a physician and you listen to my show, send me an email at onair@superhumanradio.net because we're going to set up a training seminar if you want to start prescribing rapamycin for your patients. You'll be taught everything you need to know by the guy who created the entire category of medicine. So this is very, very exciting. We have good shows all week long. We have a Blueprint Power Hour tomorrow. But that Wednesday show is going to be a barn burner. And I want to thank Faith Fitness guy. He said this was another $1 million show. Tune in Wednesday, man. I don't know how old you are, but if you're starting to get near 40, you may want to start on rapamycin. Don't wait until you're 50 and 60 like me and not age instead of having to try to stall say, I don't want to get any older than this. I'm at 62 now. I just want to, if I could stay at this, I'm fine. Like, stay at 40. This is going to be exciting. And thank you for saying that. It really means a lot. And again, if you get something from this show, please help me out by doing a short 60-second video under 3 minutes and telling me what you like about the show and upload it to shrnetwork.biz/yourstory. I will greatly appreciate it. And don't forget to enter to win a $5,700 3-person infrared sauna from Good Health Saunas. To enter, go to shrnetwork.biz free sauna. What do you got to lose? Nothing. All right, we'll see you tomorrow. Thank you for watching and listening today. And please, please, please share the show. Thank you.